Good morning. It's May 27th, and this is your daily brief in science. Here's everything you need to know. A Florida encounter with two black racer snakes grabbed attention after Robert F. Kennedy Jr. posted a video showing him handling the reptiles with his bare hands while visiting Dr. Mehmet Oz's home. His wife, Cheryl Hines, urged him to put the snakes down. The clip quickly went viral, drawing millions of views within hours, and CNN news source provided context about the snakes' behavior and noted the source of the coverage. Kennedy identified the snakes as non-venomous black racers and reiterated that they were not venomous, while Dr. Oz asked what kind of snakes they were. Florida Museum of Natural History experts say North American racers are not dangerous to people or pets, though they may bite in self-defense. Herpetologists caution that handling wildlife can stress the animals and advise against gripping by the tail, noting that snakes can bite but are not venomous or life-threatening. Wildlife experts emphasize minimizing handling duration and avoiding unsafe handling practices, aligning with wildlife welfare guidance. Experts warn that Kennedy's handling method is not advised by professionals and highlight the stress on wildlife from such encounters. Black racers are common in the region, and encounters usually end without incident when people observe from a distance. The incident underscores risks of wildlife interaction in residential Florida and reinforces guidance to observe from afar and give snakes space. The piece places Kennedy's actions in the context of his public persona and past wildlife videos, noting a history of outdoor animal encounters and controversial stunts. Cheryl Hines initially mistook the snakes for venomous moccasins, prompting alarm before their non-venomous nature was clarified. The Department of Veterans Affairs is advancing psychedelic therapy research for veterans, with MDMA trials already progressing and a new study for PTSD and alcohol use disorder launching at the VA Providence healthcare system, enrolling about 80 veterans across Providence, Rhode Island, and West Haven, Connecticut. The VA currently oversees 19 active psychedelic therapy trials, backed by over $23 million in external funding, and conducts these studies in safe, controlled clinical settings with safety protocols aligned to FDA standards. Enrollment for the new MDMA-assisted psychotherapy trial began in mid-May, employing randomized assignment between MDMA-assisted therapy and an active placebo, with rigorous safety and federal guideline adherence. Regulatory and logistical hurdles are acknowledged, including sourcing ibogaine and the need for federal approval processes, alongside ongoing clinical and cost considerations for psychedelic treatments. There is bipartisan legislative activity to expedite psychedelic therapies, including a May letter urging faster FDA action, even as FDA leadership has recently changed with the resignation of the agency's commissioner. President Trump has publicly supported expanding access to psychedelic therapies, signing an executive order aimed at speeding FDA evaluation and access for patients with major depressive disorder and substance use disorders, and coordinating among VA, FDA, and HHS. The administration's push to accelerate research on psychedelics is part of a broader effort to coordinate cross-agency action to facilitate treatment access for serious mental illness. Key voices include VA Secretary Doug Collins, clinical advocates like Dr. Lynette Averill, and perspectives from groups such as MAPS and Smart Approaches to Marijuana, highlighting a spectrum of safety, applicability, and policy views. FDA has granted accelerated pathways related to psychedelic-assisted treatments as part of the broader push, signaling a faster regulatory track for promising therapies. The trial emphasizes safety and adherence to federal guidelines, cautioning against self-medication and the substitution of psychedelics for proven, evidence-based treatments. The trial carries a clinicaltrials.gov identifier, and there is an expectation that FDA approval would be required before any public non-research use of these therapies. HHS and HHS Secretary Kennedy have voiced interest in creating controlled access pathways for military personnel with PTSD and depression to psychedelic therapies. Aging in neural progenitor cells helps shape the cortex and drive species differences in brain development. Researchers show that how long these cells stay active influences the balance of deep and upper cortical layers, contributing to species-specific structures. Across mammals, a cellular timing mechanism alters progenitor aging during early development to determine the cortical layout. The study uses cross-species comparisons, lineage tracing, gene expression profiling, and cell labeling to connect signaling dynamics with neuronal outcomes. In rats, a longer neurogenic window results in more deep-layer neurons, while mice switch sooner to producing upper-layer neurons. Extended rat neurogenesis aligns with prolonged expression of WNT signaling genes that regulate developmental timing. Comparative analyses indicate heterochronic changes adjust cortical layer proportions in a species-specific way without disrupting the cortex's overall laminar architecture. The work suggests that manipulating progenitor aging could influence brain evolution and has potential implications for developmental and neurological disorders. The findings are reported in the EMBO journal under the title Interspecific Diversity in the Neuronal Composition of the Mammalian Cortex Arises from Heterochrony in Neurogenesis, DOI 10.1038/S44318-026-00806-Z. This research from Osaka University points to signaling timing during brain development shaping the ratio of deep-layer to upper-layer neurons, contributing to species differences in cortical structure. Overall, the study provides insight into mammalian brain evolution and opens avenues for regenerative medicine research related to developmental timing and neural circuitry. Laughter isn't just sound. It engages multiple brain regions and reaches beyond speech development to influence heart rate, breathing, immune function, and the balance of cortisol, dopamine, serotonin, and endorphins. Neuroimaging shows humor activates neuroplasticity, challenges the mind to resolve conflicting ideas, and supports working memory and frontal lobe activity, fueling creative thought and memory retention. Dr. Jacqueline Harding of Middlesex University notes that laughter strengthens emotional bonds, soothes the nervous system, and boosts resilience in children, supporting healthier brain growth and learning. She emphasizes simple shared play with eye contact, smiles, and joint attention as a foundation for connection, especially valuable when children face stress or trauma. The piece frames humor as a serious contributor to learning and resilience, not mere frivolity, calling for broader acceptance and application in parenting and schooling. Early emotional experiences become embedded in the developing brain, shaping self-regulation as children grow, with adult co-regulation playing a crucial role. Harding advocates bringing humor into education to reduce cognitive load and simplify complex information, arguing that hope, humor, and human connection can refresh the educational paradigm. Humor and hope are foundational to healthy development and should be integrated into education rather than treated as frivolous. Gentle, joy-filled approaches and humor can ease cognitive load in learning, aid information digestion, and support self- and co-regulation in children, including those with trauma experiences. Laughter and playful interactions strengthen parent-child emotional bonds, raise oxytocin, and enhance neural synchrony during shared activities, potentially reducing parental burnout and stress. Humor engagement in parent-child interactions boosts oxytocin and neural synchrony, improving social skills and reducing parental burnout through close eye contact, smiles, and joint attention. Shared play and eye contact, rather than jokes, can strengthen emotional bonds and may lower parental burnout, with oxytocin rising during positive interactions. Two types of embryo-like structures created from human stem cells were launched to China's Tiangong space station aboard the Tianzhou 10 resupply mission to study early human development in microgravity. The two models, peri-implantation and perigastrulation, were cultured for 5 days in orbit and then frozen for return, enabling comparison with Earth-based controls. Astronauts are conducting the space biology experiments as part of China's broader space program. Researchers aim to map a developmental window about 14 to 21 days after fertilization, a period when organ formation begins and abnormalities can influence fetal outcomes. The study seeks to understand how microgravity and cosmic radiation affect early development and to assess potential implications for future space populations and self-sustaining off-Earth colonies. A key objective is to identify how space conditions influence conception and early growth, including the establishment of the body axis and organ formation. Earth-based control samples were cultured in parallel to isolate space-specific effects on embryogenesis. The artificial embryos cannot develop into fetuses, allowing ethical study of early development while informing challenges for long-duration space habitation. Samples included 2 development models, one simulating embryo attachment to uterine tissue and a microfluidic chip model of cellular reorganization, both developed for 5 days in orbit before freezing for return and analysis. The overarching aim is to inform protocols for growing humans off-world, assess risks to early development, and guide future space policy, medical procedures, and mission planning. This dataset provides a baseline to compare space versus ground development and to understand factors affecting embryogenesis in space. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.